The other one is involving the trig function. So for the trig function, make sure the angle is in the radian form. So when you put in a calculator, make sure you set your calculator in the radian mode. Okay. This time the function is sine x at a equals pi over 4, and use to approximate the function at 0.75. See, it's not as tricky as the second problem that we just did. As for the function, it's direct form for this problem. See the f and the f. So that means the x is 0.75 is the direct form for this example. Part 1, find the linear approximation. The a is given as pi over 4. The function at a, which is sine at pi over 4. Sine at pi over 4 or sine 45 degrees. You guys recall? Sine pi over 4 in the exact form, square root 2 over 2. Okay, keep it as the exact form. And the number that provided, they should be in the special angle that we is as a common use, like pi over 4, pi over 6, pi over 3, pi over 2, and so forth. So we have the a, we have the function at a, and the derivative at a, which is the derivative of sine x, and evaluate at x equals a, which is pi over 4. Derivative of the sine is cosine. So cosine pi over 4. It turns out to be the same. That's nice. Well, not as nice because we have the radical term, but at least it's not too complicated. So then the linear approximation or the Lx function is a function value at pi over 4 plus the derivative at pi over 4 as the slope multiplied by x minus pi over 4. It's not as nice as the number that we saw in the last two examples. So f at pi over 4 is square root 2 over 2. The f prime, square root 2 over 2, multiplied by x minus pi over 4. Okay, just leave it as the exact form. So in the box here is the line, or it's called the linear approximation that we're going to use to approximate the function at 0.75, which is the second part of the problem. So the second part, we're going to use the Lx at x equals 0.75 because the direct form here, x here, to approximate the function at 0.75, which is the sine at 0.75. Okay, so the sine at 0.75 approximately equal to, I'm gonna put a note here, f at 0.75, which is sine at 0.75, approximately equal to the linearization or the linear approximation at x at 0.75. You see the notation? This is approximately equal to, this is equal. So the linearization as the square root 2 over 2 plus square root 2 over 2 multiplied by 0.75 subtracted by pi over 4. Okay, calculator. We get 0.68207649998. You can check the number for me if you like. I make a mistake too sometimes. So we have the approximate value, the Lx, this is the approximate. Okay, let's see if we are okay or not with this approximation. Check the exact, which is the sine of 0.75, which is, this is very close. So 0.68. At least we see the same first two digits. 0.6816386 and so forth. Okay, that's a good sign. So it should give us like some good percent. I mean, very small percent as a difference when you compare the exact and the approximate. So the percent error, which is the absolute value of the difference of the approximate, or the LX that we just got, which is 0.6820764998, and then subtracted by the exact, which is, if you put in a calculator, just type inside, do not use a decimal form of it, because we want the really exact number, and divided by psi of 0.75, multiplied by 100%, and the number, it comes out to be 0.0010 and then 64%. It's very, very small. It's less than 0.1%. So this is a good approximation. And another way you can confirm it by, for the x equals 0.75 and the a, which is pi over 4. When you type in the calculator, these two values have to be close. We're going to use a reference point as a point pi over 4. Okay, pi over 4, that's the point. And with using this point, we get the linear approximation, or the line that passing through that point as the green line here. Since the 0.75 is very close to the point pi over 4, so we use the point 0.75 on the linear approximation function to approximate the psi at 0.5. So I'm gonna put another order pair to see the to compare each one. So L. So I have to zoom in very close. So that's why the percent error is very low, because it's almost on top of each other if we don't zoom very close. So as you see, the one on the green, that is the one on the approximation line, or the linear approximation. And the one on the red, that's the curve, the sine curve. And the value are very close. Okay. So if you zoom out or do as a normal, like the standard function graph, it's almost the same.